Welcome to UFly UAS Tutorials. In today's session, we will guide you through the complete process of creating a digital twin, also known as a 3D model, of a high-rise building. You will learn how to properly plan and capture the aerial images, how to set up your drone for the best exposure and clarity, and how to follow an efficient workflow that produces professional-grade results every time. We will also cover essential principles of drone mapping and 3D modeling, including flight path strategy, camera angle optimization, image overlap, and the importance of consistent lighting. By the end of this tutorial, you will understand how to turn a simple set of photos into an accurate and highly detailed 3D structure that you can use for inspections, visualizations, or client deliverables. No expensive apps, no subscriptions, and no unnecessary complications. Just your drone, the right technique, and a solid workflow. With the proper approach, you can produce professional 3D models and digital twins without spending a single dollar on software. Let's get started. One important thing to understand about drone mapping and 3D modeling is that the best time to capture your images is on an overcast day. As you can see here, the sky is fully covered with clouds, and there is no direct sunlight. This kind of lighting keeps your exposure consistent, preserves natural color tones, and prevents harsh shadows from appearing in your 3D model. If you attempt this on a sunny day, you will end up with strong contrasts, blown-out highlights on one side of the structure, and deep shadows on the other, which can negatively affect both the reconstruction quality and the realism of your model. Whenever possible, plan your mapping missions on overcast days to ensure the cleanest, most uniform results. Now that the drone is in the air and the entire building is within the frame, begin with a wide orbit, keeping the whole structure fully visible. Completing this first outer orbit gives the software a strong foundation by providing excellent image overlap and cleaner stitching. Once you have finished the wide orbit, move the drone in closer to the building and perform additional orbits at a tighter distance. These closer passes will capture finer details, sharper textures, and more accurate geometry. The combination of both the wide and close orbits ensures that your final 3D model is highly detailed, properly aligned, and reconstructed with maximum clarity. Now that we're ready to begin our orbit and the building is fully centered in the frame, the next step is to configure the camera settings. Open the camera menu by tapping the video icon and switch it from video to photo mode. Select the time shot option and set your interval to 5 seconds. Next, switch your camera from auto mode to pro mode. Start by adjusting your white balance. Set it to auto and allow the drone to detect the correct lighting conditions for the scene. Once it settles on the proper temperature, turn auto off to lock the white balance in place. This prevents any color shifts during the flight and ensures all your images remain consistent throughout the entire orbit. Next, set your image format to JPEG and keep your aspect ratio at 4/3 to capture the highest possible image quality. Adjust your resolution to 50 megapixels to ensure highest image quality. Finally, confirm that your storage location is set to your memory card, so all captured images are safely saved for processing later. Now let's configure the ISO and shutter speed. Start by setting both ISO and shutter speed to auto, allowing the camera to automatically determine the correct exposure for the current lighting conditions. Once the camera settles on the ideal settings, switch auto off for both ISO and shutter speed to lock those values in place. This will give your light meter a value of 0, ensuring perfect and consistent lighting across all your images. If you were wondering what MM stands for, it refers to metered manual, which is essentially your light meter. It indicates whether your exposure is properly balanced, helping you maintain the ideal lighting throughout your capture process. Now that all of our camera settings are in place, highlight the building on your screen to activate Active Track and select Point of Interest mode. This will help the drone maintain a smooth and steady orbit around the structure. Set your flight speed to about 6 miles per hour, or as close as you can, to ensure stable motion. Enable the 5-second interval photo capture, and the drone will automatically take evenly spaced images throughout the orbit. This consistent speed and timing will provide excellent overlap, giving you clean and reliable data for your 3D reconstruction. While the drone is performing its orbit, keep a close eye on the building to ensure it stays perfectly centered in your frame. Point of interest tracking is helpful, but it is not flawless and may occasionally drift or shift your positioning. The advantage is that you can manually correct the drone's path at any time to maintain a consistent distance and keep the building properly framed. This hands-on adjustment ensures your photos remain uniform and ideal for high-quality 3D reconstruction. Be patient and allow the drone to capture the entire building while keeping it fully in frame. Make any necessary adjustments to ensure the structure remains centered on your screen throughout the orbit. It's also a good habit to begin each orbit at a specific landmark so you can easily identify when the orbit is complete. In this example, I use the pool as my starting and ending reference point for every pass around the building. Now that our wide-angle orbit is complete, we can begin moving in closer to capture the finer details required for a high-quality 3D model. Beginning at the top, use the same settings as before to capture higher-quality texture images. Adjust your gimbal pitch as needed to ensure the building is framed correctly and remains the primary focus of your shot, making sure the sky is minimized in the frame so it doesn't interfere with the reconstruction. The goal is to have only the upper portion of the building centered in the shot, capturing clear and consistent details of the structure. The closer you position the drone to the structure, the more detailed and accurate your textures will be. This step is essential for producing a crisp and a more realistic 3D model with clean surface detail. Keep a close eye on the orbit to maintain a consistent distance from the building, as point-of-interest tracking can occasionally drift or shift. The more you monitor and correct your position during the orbit, the better results you will achieve in your final 3D model. Now that the orbit has finished, I will stop the tracking and turn off the 5-second interval capture. From here, I'll make the necessary adjustments for our next orbit, continuing to use the same settings and techniques to ensure consistent and high-quality results. Our goal is to complete 3 close-range orbits around the structure, in addition to the initial wide-angle orbit. In total, you should have approximately 4 full orbits, giving you the coverage and detail needed for a high-quality 3D reconstruction. Try to maintain the same distance from the building during each orbit and use the exact same camera settings for every pass. Make any necessary adjustments as you fly the orbit to ensure the structure stays centered in the frame at all times. Take your time and avoid rushing the process. A slow, controlled flight with careful attention to framing and consistency will always produce better results. Great. Now that we've completed our second close-range orbit, we can move on to the final pass at the lower section of the building. This orbit will focus on capturing the base and the lower levels of the structure while maintaining the same distance from the building and using the exact same camera settings. This consistency ensures your 3D model has accurate detail from top to bottom. This is coming together beautifully, especially considering that I didn't need to purchase any apps or pay for any subscriptions that can quickly add up. All you really need is solid technique, a reliable workflow, and the right conditions. Capturing your images on a perfect overcast day ensures you get the best possible photo quality for your 3D model without spending a single dollar on software. I will complete an additional orbit that focuses solely on the base of the structure, capturing the street level and the lower surrounding area. This extra pass will help gather more detailed imagery of the pool area, the sidewalks, and the street-level environment, ensuring the final 3D model has strong detail and accuracy in these lower sections. Now that we have finished capturing all the images needed for the 3D model, let's head over to the computer and begin processing the data. We captured a total of 286 images to cover the entire high-rise building, providing more than enough data for a clean 3D reconstruction. Begin by creating a folder on your desktop and transferring all the images from your SD card into that folder. This keeps everything organized and ensures all your files are ready for processing in one central location. If I continue to receive enough likes, views, and followers on these 3D photogrammetry tutorials, I will create even more beginner-friendly step-by-step guides to help you grow in this field. Make sure to watch the other tutorials available here on my channel, and don't forget to subscribe and turn on notifications so you never miss a new video. My goal is to teach you how to generate real income with your drone without wasting money on overpriced apps or expensive subscriptions that drain your budget. All you need is the right technique and the proper workflow, and I'm here to guide you every step of the way. Your support motivates me to continue producing high-quality tutorials, so please consider subscribing. Now that all the images are organized in one folder, open RealityScan. Once RealityScan is open, select Workflow, then choose Add Folder and navigate to the folder containing your images. Then click Select Folder. RealityScan will begin indexing all the photos. The next step is to align your photos. Click Alignment, then select Align Images. RealityScan will begin processing and aligning all your images, generating a point cloud that you can review and analyze. This process will vary depending on the number of images you are aligning and the performance capabilities of your computer. Faster hardware will complete the alignment more quickly, while larger image sets may take longer to process. Great! The alignment is complete. Now let's take a look at the point cloud. First, let's get a better view. Go to Scene 3D, then click on View, and simply uncheck Residuals. This removes all those extra lines on the screen so you can clearly see your point cloud and all the camera positions from your flight. Now let's take a look at all the orbits we captured during the flight. You can see that we started with a wide-angle orbit around the entire structure, giving us a strong exterior foundation for the model. Then we moved in closer and began our top orbit, flying a tight circle around the upper floors to capture all those details. After that, we continued performing multiple descending orbits, each one a little lower than the previous, gradually working our way down the building. This consistent overlap is what allows you to get great results. This is where knowing the correct workflow really pays off. When you understand your overlap, your drone speed, and how to plan your orbits, you can achieve results like this every single time. And the best part? I didn't use any paid apps, no expensive subscriptions, just the right technique, the right capture strategy, and a lot of patience. Now let's adjust the region box, also known as the bounding box, to clean up our workspace. By resizing this box, we can trim out all the unnecessary points that we don't need RealityScan to process. Keeping the region tight helps in two ways. It reduces processing time and ensures RealityScan focuses only on the area we actually want to reconstruct. This makes the workflow faster, cleaner, and much more efficient. Take your time when resizing the region box. Be very careful not to cut off any part of your model. Gently align the box so it only surrounds the area of your structure that you actually want to keep. Don't rush this step. A clean, well-framed region will give you much better results later in the reconstruction. If your building has antennas, like this one did, it's always better to fly a very close orbit around them. Antennas are thin and detailed, so the closer you get during capture, the better RealityScan will be able to reconstruct those fine structures later on. Right now, I'm adjusting the region box, and I'm making sure I'm not cutting off any of those antennas at the top of the building. Always double-check this area, because even a small trim can remove important details you worked hard to capture. Now that we're happy with our region box adjustments, let's move on to the next step. Go ahead and click on Mesh Model, and then select Preview. This will generate a quick preview mesh so you can check the overall shape and make sure everything reconstructed correctly before moving on to the final high-quality mesh. Now that the preview mesh is generated, I'm going to make a few final adjustments to the region box. This helps trim out any extra points that aren't important for our model, keeping the reconstruction clean and focused on the structure itself. Go ahead and click View under Scene 3D panel and activate Vertices. This lets you take a much closer look at the individual points in your model, making it easier to identify any areas you might want to clean up before moving forward. I'd like to remove this building in the background since we don't need it to be processed. To do that, I'm going to click on Tools and select the Lasso tool. All you have to do is click and hold the left mouse button, then draw a lasso around the area you want to clean up. Once you release the button, that entire region will be selected. Once it's selected, just hit Filter Selection, and RealityScan will delete those unwanted points from the scene. Now that I'm happy with the cleanup process and I've removed all the unnecessary points, there's one thing you should keep in mind. Every time you hit Filter Selection, RealityScan creates a new model in your left panel. Once you're done and you reach the final version with all the cleanup you need, you can safely delete all the other models if you want. Just make sure you don't delete the very first one, since that's your original model. Let's go ahead and disable the cameras to clear up the view. Click View under Scene 3D and uncheck the box that says Enable. Now click on Mesh Model and select High Detail. This will generate a high detail mesh of your structure. If you don't need that level of detail, you can select Normal Detail, which will still produce a very clean and accurate mesh. The time it takes to generate a high-detail mesh will depend on two things: the number of images you captured and the overall performance of your computer, especially your graphics card. More images and lower GPU power will take longer, while a strong graphics card will speed up the process significantly. On my laptop, this process took 1 hour and 36 minutes using an NVIDIA GeForce RTX 4080 with 32 gigabytes of memory. Just be patient and let RealityScan do all the hard work. This is a perfect time to step back, take a break, and let the software finish adding the high-detail mesh to your model. The high-detail mesh looks incredible. I can even see the antennas on the roof of the building in the mesh. This is crazy. Look at the amount of detail we were able to capture. This is a perfect time to save your work. Let's go ahead and do that now. Click on the RealityScan icon, and then click Save. Now that our work is saved, let's go ahead and unwrap the model. You might be wondering why we need to unwrap it. Unwrapping prepares the surface of your mesh, so RealityScan can generate clean, accurate textures. Think of it like flattening the 3D geometry into a 2D layout. This allows the software to paint the texture back onto the model with the highest level of detail. Under the Mesh Model tab, click Unwrap. This will open the Unwrap settings in the left panel. I like to keep my maximum texture resolution set to 8192 by 8192, and the style set to maximum texture count. These settings give you the best possible texture quality for your model. Next, click Unwrap, and RealityScan will begin the unwrapping process. If your unwrapping fails, like it just did here on my computer, don't worry. All you need to do is increase the maximum texture count to a higher number instead of keeping it at 1. In this case, I'm going to bump it up to 5 and click Unwrap again. Great. Now that the unwrapping was successful, let's save the project one more time. After saving, we can move on to texturing the model. Under the Mesh Model tab, click Texture. This will generate the final textured version of your 3D model. The texturing process can vary depending on your system, but on my computer it only took about 11 minutes. Just be patient and let RealityScan generate the final textures. This is where all your hard work, preparation, and workflow really pay off. You finally get to see your 3D model come to life, beautifully, accurately, and with incredible detail. And the best part? You did all of this without spending a single dollar. Just solid technique, smart planning, and the right workflow. Now that we're happy with our final textured result, let's create a 3D video animation. First, let's expand the interface so we have more screen real estate for the animation tools. If you want to match my layout, I'm using the 1+2 view here. Make sure one window is set to 3D view and the other window is set to 4D view so you can see both the model and the animation timeline while you work. Let's go ahead and clear the region box. To do this, click on Tools under Scene 3D. Then open the drop-down next to Set Reconstruction Region and select Clear Region. Adjust your 4D window and then set your 3D model to the exact view you want your animation to begin. Once you have that starting angle, click Add Keyframe. Next, rotate your model to the next position you want to show and click Add Keyframe again. Continue doing this step by step until you build a smooth, cinematic camera path that shows off your 3D model beautifully. If you make a mistake on any keyframe, don't worry. Just select that keyframe and hit Delete to remove it. Continue adding keyframes to build a smooth, cinematic video sequence. Use your creativity to decide how you want to showcase your 3D model, whether through dynamic fly-throughs, dramatic angles, or slow, sweeping movements. You have full control over how your animation is presented, so feel free to experiment with different settings and transitions to create the most engaging and visually appealing result. Once your keyframes are set, go to the timeline and space them out evenly. You can also extend the length of your video by dragging the timeline to the left. This allows you to create longer animations, whether you want a 40-second sequence or a full minute. Just continue spacing your keyframes at equal distances until you are fully satisfied with the smoothness and flow of your animation. Adjust them as needed until everything looks exactly the way you want. Next, move the playhead to the beginning of your timeline and uncheck the box labeled Show 3D Path to hide the camera indicators. Then click Play to preview your animation. Make sure it looks smooth, cinematic, and professional, showcasing your 3D model from every angle while ensuring that all movements flow naturally from start to finish. Take your time when creating these video animations and feel free to experiment with different transitions and viewing angles. I am very happy with the results, and the high-rise building came out beautifully with an impressive amount of detail. The DJI Mini 5 Pro's 50-megapixel image quality truly stands out, and everything looks incredible in the final 3D model. Our next step is to export the video animation, so let's go ahead and do that. Click Export to begin the process and prepare your final cinematic animation for rendering. Take a moment to match all of your export settings to the ones shown in my window. This will ensure you get a smooth, high-quality video animation render with the best possible results. Then, click OK. Choose the folder where you want to save your video animation and click Save. The rendering process will begin, and the time it takes will depend on the video resolution you selected and the performance of your computer. Open the folder where you saved the video animation and play it back to review the final result. This gives you a clear view of your completed cinematic sequence exactly as it will appear to your audience. I typically share these video animations with clients through YouTube. Simply upload the video to your channel, set it to unlisted, and send the link to your client so they can view it easily and securely. Congratulations on completing this high-rise 3D photogrammetry tutorial for beginners. If you found value in this lesson or learned something new, please consider subscribing and giving the video a like. Your support truly makes a difference, and if I receive enough views, likes, and engagement, I will continue creating more detailed and beginner-friendly tutorials just like this. Thank you for watching, and I'll see you in the next one.